In racing circles, the 24 Hours of Le Mans is considered the pinnacle of endurance, where winning is often determined not only by who has the fastest car, but by which team can avoid mistakes or overcome a crippling mechanical failure. Now imagine that level of concentration in a competition that runs 4 years. The DEP's Brianna Hickman joins us now with the details.
Jake, it's called the EcoCAR3 Advanced Vehicle Technology Competition, and it goes something like this. Take a well-known performance car, the Chevrolet Camaro, and develop and integrate energy-efficient technologies into the powertrain that maximize performance, all while retaining the safety and build quality standards of the original. West Virginia University is one of 16 teams now approaching the finish line, and with the checkered flag almost in sight, they're looking for a podium finish.
Start it up.
It's down to the wire. The hard work of 4 years of design, mock-up, fabrication, testing, evaluation, and refinement is almost finished. WVU entered the final year of the competition in 4th place among 16 schools, and team members are looking to finish strong.
We're striving to win, so we're not holding back at all. It's not like we're sitting in a comfortable spot. We're pushing forward, trying to do every little bit that we think the other teams will be doing.
I am cautiously optimistic that we will finish at least as well, if not better, than we did last year. We have a really, really good car by competition standards, and we've been told so by many of the organizers that we really like your car. You guys have done and built a very good vehicle. And I think a lot of them have been surprised because we weren't in the last competition.
With an earlier generation of performance cars, powertrain upgrades were a fairly straightforward process. For modern cars with their multitude of vehicle-specific sensors and computer controls, simply dropping a more powerful engine under the hood isn't all that simple.
One of the main design decisions we made with our vehicle was to remove the V6, the original stock V6 Camaro, or stock V6 engine from the Camaro, and put in the 4-cylinder from the Equinox in order to improve fuel economy and decrease overall emissions, burn less fuel. Basically tricking all the computers in the vehicle to convince the entire Camaro that there is a 2016 engine in the car when there's in reality a 2014 engine in the car, and vice versa. So having to convince the engine that there's a 2014 car surrounding it. That's posed the most significant problem for us.
And then there's the car's electric motor and battery system. You see, this Camaro is a hybrid. The addition of a powerful electric motor brings the performance back to the level of the stock V6. Getting all those specialized components to work together consistently has not been easy.
One of the most challenging things is doing the diagnosis. I mean, doing diagnostics and stuff. There's a lot of little quirks and things with our car because it's not a stock car. We have a lot of aftermarket or non-regular items on the vehicle, and sometimes it's complicated to trace down everything to figure out what's actually going wrong with the vehicle.
But this is more than just an engineering exercise. Part of the competition is producing a vehicle that buyers would want to purchase.
Going into year 4, we really move into the refinement stage and getting into the consumer appeal aspect of the car. So we started with just aesthetics, painting the car. We'll work into the ride quality and drive quality of it, how it feels on the road, how it deals with imperfections in the roads, which is very common in West Virginia, unfortunately, but we definitely make note of it. And then also just lightening up the car to help with the performance aspect and just overall customer satisfaction.
Probably the most significant part of this exercise, or this engineering exercise as a program as a whole, is evaluating design decisions. You have to really open your eyes and see the entire scope of the work that you're doing. It's also very interdisciplinary too, so being able to work with engineers from other disciplines like mechanical, industrial, all those sorts of different fields, taking into consideration safety. So all these components that you're putting in the vehicle, you're putting a driver in the driver's seat. So you have to think about every single design decision that you make needs to reflect the importance of safety for the consumer.
These days, most of the driving is done on a dynamometer. A device the car is secured to while a set of rollers under the rear wheels provides rolling resistance, measuring speed, distance, and power output.
We're in the process of trying to log miles on the vehicle. They want to make sure that this year especially, that these vehicles can get out and do all of the dynamic testing they need to do, and eventually compete in an over-the-road event where we're going to actually drive around the Los Angeles area for several hundred miles as a convoy of several convoys of Camaros painted all different colors. And so we have to do what's called an endurance drive. And we're expected by the end of March to log 1,000 miles on the car since August, and to log a 100-mile endurance test and a 200-mile endurance test. And those tests aren't just driving. We have to take data from the vehicle, thermal systems, all of the controls information. You have to read the controller area network or CAN data, and then look at energy consumption. Because the whole idea is if you're going to break something, break it now.
And that's the hands-on problem-solving experience that you can't get in a classroom.
That's probably one of the largest differences between a classroom setting and a program like this is you get that true experience of you're putting something onto the vehicle that you're going to be driving. So you have to there's a level of importance there in evaluating the strength of your design decisions and essentially the robustness of the functionality of whatever you're developing.
And it's that experience that is the measure of the value of this program.
This program, I've learned a lot more than I ever thought I would, being the faculty advisor. And so that's one of the things that surprised me. Another thing I think that's really surprised me is over the last few years is how passionate some of the students really are about this program. Matt, for instance, came on as our engineering manager, a year and a half ago, and to see these students mature and learn a lot, but the passion they have and the ownership they take of the program and how proud they are to talk about and be associated with these programs, I don't think I really understood that aspect of it, because I knew students would do this for more than a grade, but I didn't realize how passionate some of the students would be.
A program like this gives students ample opportunity to explore the incredible amount of engineering that goes into the automotive industry. I mean, that I think alone is probably the biggest eye-opening part of this whole program. For me personally, I actually received an offer from General Motors to begin working with them in August. So I will be making a career out of the automotive industry. I never anticipated being an engineer in the automotive industry until I started working on this program.
Up next for the team, stops at the General Motors Desert Proving Ground in Yuma, Arizona, and the Auto Club Speedway in Fontana, California, where NASCAR races, for a series of dynamic tests and then finally on to Los Angeles for the finals. For Environment Matters, I'm Brianna Hickman.
Thank you, Brianna. Dr. Nick says they're already working on a proposal for the next as yet unnamed competition.